Infectious diseases are the most common of all the diseases that affect us. For many centuries, the real cause of infectious diseases was not known. Late in the 19th century, a French chemist, Louis Pasteur, discovered that certain living microorganisms are the cause of infectious diseases. Today we call these organisms pathogenic microorganisms, which means disease-causing microorganisms. As scientists learned more about pathogenic microorganisms, they developed a number of man-made defenses against them. Some man-made defenses, such as the pasteurization of milk, destroy microorganisms by heat. Another relatively simple method, the chlorination of water, destroys microorganisms by the use of chemicals. Other important man-made defenses are the many pharmaceutical substances which we commonly call drugs. Before seeing how drugs may be used to prevent or cure infectious diseases, we should remember that the human body has a natural system of body defenses against infectious diseases. For instance, the skin serves as an effective outer body defense against pathogenic microorganisms. The mucous lining of the nose, throat, and other parts of the body is an effective inner body defense. But the most complex body defense is immunity. Immunity is the body's ability to resist a specific infectious disease. Immunity may be naturally acquired or artificially acquired. Let's see an example of naturally acquired immunity. If you had a childhood disease such as measles, your body developed its own defense against the disease by producing antibodies. Antibodies are chemical substances in the blood that destroy the microorganisms causing the measles. Because your body produced antibodies, you recovered. You were immune to further attacks of measles. Such immunity is called naturally acquired immunity, because it is acquired while having the disease. But is it always necessary to recover from an infectious disease in order to acquire immunity? No, because we can provide immunity artificially by inoculation. In order to understand immunity that may be artificially acquired, we must understand two more words, passive and active. First, let's see how immunity that is artificially acquired may be passive. This nurse will receive an injection of antitoxin. This diphtheria antitoxin will neutralize the toxin or poison produced by diphtheria microorganisms. The antitoxin will give the nurse passive immunity to diphtheria. Passive immunity usually lasts only 2 or 3 weeks. It is called passive because the nurse did not produce the antibodies. Let's see where the antibodies were produced. Diphtheria antitoxin is produced by injecting large amounts of diphtheria toxin or poison into the body of an animal. The toxin will cause the horse's body to produce great quantities of diphtheria antibodies, which are called antitoxin. After several days, some of the blood containing the antitoxin is withdrawn from the horse. After processing to remove other substances, the antitoxin can now be used to provide a temporary or passive immunity, as we saw. Now let's see how active immunity may be acquired artificially. Active immunity is artificially acquired through the use of vaccines, another kind of pharmaceutical preparation. Vaccines differ from antitoxins in that they do not contain antibodies. When introduced into the human body, vaccines stimulate the body to develop its own antibodies. So remember that vaccines, like antitoxins, provide immunity that has been artificially acquired. Vaccines provide an immunity that is called active. It is called active because your body actively produces the antibodies. Active immunity often lasts for many years. Let's learn more about the pharmaceutical preparations called vaccines. Smallpox vaccine, for example, is usually produced in a calf. After the calf has been anesthetized, a portion of its skin is inoculated with a pure living microorganism, in this case, pox virus. When sufficient time has elapsed for the virus to multiply in the calf's skin, the material containing the virus is collected. It will then be made into a vaccine which is used to provide active immunity. The vaccine contains virus as we see it here through an electron microscope. Vaccines can also be prepared in other ways. Here, influenza microorganisms are being injected into fertile chicken eggs. The microorganisms will multiply in the eggs. But no matter what production method is used, all vaccines provide active immunity by stimulating your body to produce antibodies. Vaccines and antitoxins are two important man-made defenses generally used in the prevention of infectious diseases. Now let's learn about pharmaceutical preparations that are used in the treatment of infectious diseases. They are synthetics and antibiotics. First, let's learn about the synthetic drugs, which are made by synthetically combining chemicals to form compounds. The big advantage of synthetic drugs is that chemists can control the exact composition of a drug. For example, the molecular structure of a synthetic drug, such as sulfanilamide, may be altered. By changing the molecular structure, new compounds may be formed that give specific results against certain infectious diseases. In addition to the synthetics, another group of pharmaceuticals, antibiotics, are also effective in the treatment of infectious diseases. Antibiotics are produced by molds and bacteria, usually found in the soil. Antibiotic-producing molds, such as these, can be grown from dilute solutions of soil. The effectiveness of a pure mold can be tested. Here, the antibiotic mold has been grown across the center of this petri dish. We can see that the antibiotic has stopped or inhibited the growth of two of the pathogenic microorganisms growing on the dish. Growth inhibition is one way that antibiotics destroy pathogenic microorganisms. Here we see the blue mold that produces penicillin. Like all antibiotics, penicillin starts production as a pure mold called a culture. As the culture grows, it is transferred into larger and larger tanks, finally reaching maturity in huge tanks such as these. The fully developed antibiotic is then separated from the mold fibers, purified and processed into powders, tablets, ointments, and solutions. Among the hundreds of antibiotics known today are many of our most effective man-made defenses against disease. We have learned much since Pasteur's discovery in the 19th century that diseases are caused by pathogenic microorganisms. The human body has certain natural defenses that help to protect it from pathogenic microorganisms. We have learned that we can develop active immunity to a specific disease if we contract the disease and recover from it. We also learned that vaccines and antitoxins will provide immunity to specific infectious diseases. Such drugs provide immunity that is artificially acquired and may be passive or active. We have also seen that certain drugs, the synthetics and the antibiotics, can be used to help your body fight infectious diseases while your body is acquiring immunity. As we learn more about pathogenic microorganisms and their behavior, we will be able to develop even more effective man-made defenses against infectious diseases.